I'm going to give the general introduction and all of the functionality within a single project. This is going to be a hands-on session. I hope you have OpenRefine installed already. Let's start with an introduction to OpenRefine. It was initially developed under the name Google Refine by Google, obviously, but it was later made open source and given to the community because it didn't really fit the Google product canon, largely because one of the core principles is that the software runs on your own computer and the files stay on your computer. So there's no upload to the cloud. And it's a bit more technical than most of the general Google products. It was renamed to OpenRefine, but there are still some traces left of Google branding within. I know some of the core developers, they have a really tight connection to the Wikidata and Wikibase community, so many influences are also coming from there. The test data, it's a training data set, and it's from a data set snapshot of the herbarium at the Botanic Garden and Botanical Museum. To start OpenRefine, it should first open up a console window that would look like this. You can ignore that window for now, and it should then automatically open up this screen. You can enter this IP in your browser. So once we are done, we create a new project and then select the winter scroll and select the training data set that you downloaded. By default, it should recognize all of the columns automatically. It will recognize that the first row are the column names. It will check the character encoding. So you shouldn't have to do anything here. If you're working on the server version, I would recommend that you rename the project to something that includes your name. So we don't have problems with several data sets having the same name. We click on Create Project and it will show you the initial project screen. First of all, one of the things that I always do is I increase the number of rows that are shown. So up here you have the navigation. You can browse through the various pages. Since we currently have 1,136 rows, we can see them now in increments of 500. The view rows and records is not relevant for us. Sometimes when you have data that is structured a bit differently, where the first column has spaces, it will group them by the first column, and you then have records. And now we want to take a look on the data. And one of the most practical ways to do this in OpenRefine are the facets. So if you select any column, let's just use the family, and then you see facet. We have, for instance, the text facet. There are other types, but text facet is the most important one if you have text space. And it will group all of the records and it will list them alphabetically, and it will show you how many there are for each family. And I can simply select one and then see all of the records from that particular family. But we can also sort them by count. We see which one are the largest groups, and switch around here a bit. We can also select multiples. We go over here and say include. So if you want to pick a section that includes several of those, we can combine them. And all of the facets also have the option to invert them. That is sometimes really practical. Everything but what I selected makes it instantly recognizable that you're now in the inverted mode by crossing out the ones, and you can then exclude. Sometimes if you have really large data sets, and we are talking here 100,000 plus, then those facets take a while to generate, and every action takes 1 or 2 seconds, which is a bit annoying. You can, of course, combine multiple facets. Here on the regular mode, we select those 3 families. And then you see the instance we select this, we have a reduced set. We see how many are currently matching that filter. And we can add a second facet and now show all of the full scientific names for the ones that are filtered by the previous ones. Again, we can go by count. That's boring because all of the ones only have 1. So it doesn't really change. And we can inspect them a bit further. We have filters. Filters are like search boxes. Close this one. And we are looking for a certain name. For instance, here we have multiple ones that start with salvia. And now it filters all of the ones that contain that string. This, of course, has an influence on the facet up here. So we can see the ones we selected only belong to that family. Not surprising, but one of the most common tools to reduce or to select subparts of the dataset. This is the column menu up here. And many of the actions we will do today on individual columns is through this menu. Instead of selecting individual ones, you can always just click reset up here and it will reset the entire filter. Or even reset all if you have multiples and just want to go back to the overview. If it helps, drag and drop those around, change the order. Sometimes it helps to just reduce the size of the filters or inversely increase to get a better overview of what's in here, or at least for the facets. Let's start with editing. Since this is a dummy data set, we don't really care if we just edit for the sake of editing. For instance, let's say we find a typo in one of the names, somebody entered it wrong, or there was an OCR error. Just hover over a cell and you see the edit menu, and you can then just change something here and click apply, and it now has changed. And let's say you found a systematic error. Let's just pretend we have an error here. Let's just pretend it's supposed to be a T-nome with a T instead of a P. I know we have 3 records. Of course, I could go into every single one of them and edit this. That's a bit annoying, especially if there are more than 3. But there's a secondary button here called apply to all identical cells. So if the same value appears in other cells of this column, with just one click, you can fix all of them. In that filter here, I still have the old one selected. I need to reset the filter, and we now see it's in here. It's always an issue if you edit a value that is also part of a filter condition. Then, of course, you will lose it. But there's a slight distinction. If you do this manually, as I did previously, just apply, then it will actually stay until you do any other changes with the filters. So if I filter here, apply the facet for the family, even though there is only one. So in theory, it shouldn't filter down. But once I do this, then all of the filters are reapplied, and I only get the ones that are still matching. That can sometimes be a bit annoying when you edit something and then all of a sudden it vanishes. In particular, if you use the apply to all identicals, then it will automatically update once you hit the apply button. Those are the core functionalities of facets, filters, and edits. I'm now asking you to at first remove all of the question mark in the column collector name, reset all of the filters. Second, I want you to figure out in which country were the second most specimens collected. Since this is from a German herbarium, it's not a surprise that most of them are from Germany, besides the ones where we don't know the country. And how many specimens were collected by Alexander von Humboldt? I'm going to start with the results on the first one. That was the task for apply to all identicals. You select one of the question marks, just empty out the field and click apply to all identicals. I didn't check how many question marks we had, but there were a couple. Which country were the second most specimens collected from? The answer is Greece. And for the question regarding Alexander von Humboldt, The answer is 31. And here the trick is to not use the filter because C appears multiple times in different combinations, well, sometimes alone and together with en plan, but with different orderings of the names. So just putting Humboldt in the filter will show up all of those cases. You can see the answer is 31. We continue with the tour on the user interface. Sometimes there are datasets with a lot of columns you don't really need for your current task. So it's useful just to hide them. Column menu, view, collapse this column. And that will make the column small. You can particularly helps when some of the columns have a lot of text. Try another one. And we see they're still there. And I do need one of those back now. Which one is it? Just hover over it. And once you just click it, you click on the little triangle, expand it again. For this data set, we already had proper column headers. Sometimes that's not the case. Go to the context menu and go on Edit Column. And there we have Rename Column. Change the name, let's say location details becomes location description. For instance, because we want to align this with some other standard or something or some other data set. And on here, move column to the beginning, move column to the end, move column left, move column right. Sometimes when we have a lot of columns and we really need to reorder them, you can imagine that this is quite a task to remove 20 columns. So there's also another way of doing this. This applies to all columns and edit columns. There we have reorder and remove. If we click on this, we see the columns as this bunch of bars here. And here we can easily drag and drop, reorder them in the order we need. Or if we load it in a huge data set, but we are only interested in some of the columns, and the other ones we just don't need at all, there's not even a point in hiding them, we can just move them over here and remove them from the set completely. We could even click remove all and only select the ones we care about. For now, we want to keep those columns. Next comes the sorting. If we look over here, next to each row, we have two icons, one for a star and one for a flag. This is just a way to mark certain rows. There's no general purpose for that. It's up to you on how you want to use them. But the general implication is that starring a row means it's good, and flagging a row means there are issues. It could be that it is an issue and say, okay, I need to look at this later, and it's my internal to-do list. But it could also mean like those are the rows that we are going to exclude because they're not fit for whatever our research question is at the moment. Similar to this, you can also, of course, facet by star and by flag. So overview. So here we see the start rows. So it'll only show me the start rows or only show me the ones that are not start. OpenRefine is not a spreadsheet editing tool. In Excel, you can also put the comments on the cell itself, but there's no functionality like this. You can do this by creating a new column and just putting your own remarks there, but it's not possible to do as a cell metadata, if you want to call it like that. Regarding the stars and the flags, it's also possible to mass annotate them. If you have a certain filter or facet selected, edit here, edit rows and star rows. Now we come to the transformations. There are some which are really useful and you will use them a lot. Context menu of the column, edit cells, transform function. We have some others, for instance, fill down or blank down. Fill down is, for instance, when you have empty rows. That's similar to Excel when you just drag and drop to extend a cell downward. For instance, here we have the collector name. Because of the nature of the data set, it is implied that these two empty cells also should contain the value JH Schlieben and fill down, and it will automatically do that. And in a similar way, blank down is the inverse when you have multiple values being the same, like here in Brazil. And for this data set, we want to remove the last two, but only keep the first one. Whenever you get in a new data set and want to work on trim leading and trailing white spaces and collapse consecutive white spaces. So this means if you have a cell that was imported from Excel and the person editing it has put a space at the end of the value of the cell, then if you filter for some things, sometimes those don't properly match them and can cause some headache. And the same like for the consecutive white spaces. If you have, for instance, double spaces in there, then you wonder why doesn't your filter match until you realize, oh no, there's a double white space. It's really useful just to do this in the beginning. Let's just do this trim leading. In this case, we see this transformation had 0 cell results, so it wasn't really necessary. And the same with consecutive. So in this case here, it wouldn't not have been necessary. I should have maybe messed up the data a bit more before uploading the data set, so this actually gets results. But in the same option we can find here, again, for all, edit all columns. And this is the one particularly in the beginning of a project. When you load a new project, just make it a habit to do this for pretty much all of the columns, unless you know there's certain columns where it actually makes a difference. Again, do this for all. Unfortunately, here we don't see the results on how many were affected. We have double space in here, apply. And for a single column, if I now just search for double space in here, the same I can also do for leading and trailing white spaces. It's not possible to have one that says, show me all of the ones that have double spaces across all of the columns. Back to the side, removing stars and search and replace. So this is the other one. So when you have something that you want to name or something that you want to change, but it's not as easy as the edit all identical. We pick one of the genuses and we filter it by that particular genus. And let's say we want to change that genus to something else. I don't know, it was renamed or something like that. But now we see we have very different results here. We could do this all by hand, but there's also the possibility to go on replace and just say, find that one and replace it with, I don't say this for all. Of course, our filter, which was now set to the old name, doesn't show us any results. So we need to do the changes here as well. And we can now see the results. Search and replace within the string of a column. And the next feature, that one is really useful when you have quite messy data that's coming from human input. We have the location description here. And we go on edit cells again. And then cluster and edit, the cluster functionality will automatically recognize names that are similar to each other. For instance, here, it's a location description. We have the botanic garden in Indonesia here, spelled in different ways. And we can just say that is all the same location. Selecting this for measure and can then select which new name should it have. Let's say the question mark here. I then select merge selected and recluster or merge selected and close. And similar here, Südwest Africa. So this is the German name of the country that is now Namibia when it was under South African rule. This is like the historic combination that is on the herbarium sheet by the time it was collected. We are keeping this. The care principles. This would also be a case to treat this accordingly. There are different methods of finding the outlet. You have a lot of options here. Key collision, nearest neighbor collisions, with distance functions and radiuses. And there's no good answer on what to use here. It also depends on your context. For instance, when you have multiple people, and sometimes in that context, the order of the names is important and sometimes it isn't. And if it is important, the nearest neighbor collision would be a better way to match them. When it isn't, it's the key collision that's better suitable. My recommendation is just to play around, and if you are at the point where you get too many false positives here, so too many cases where it detects a potential collision, but they are actually not, then you've stretched the limits too far of that particular algorithm. It's time for the second round of tasks. This time we don't have a round of solutions because the task was to use the collector name and do the clustering and editing and find useful clusters. Over here, we see the undo and redo section. And in here, we see a list of all of the steps we did and also how many cells or rows were affected when doing a certain action. For instance, we see here when I clicked on removing the white spaces on the different cells, you can see that internally it would send the same command to each column. But again, there were no description. We can also see the flagging. And to undo a step, just to click on the one you wanted before. So going back and forth, you just click on the ones you want and you get set back to that state. And to redo, you just click on later one. Of course, once you edit something after you have undone things, then all of those changes get lost. I will get a window telling me which changes will get lost if I do this. I apply anyway, and then those previous changes were lost. And then regarding the question on how to document the changes, there we have two buttons up here. That's also really useful when redoing things you did with a different but similar data set. So when we click extract, we see the changes we did here. Some are in gray. Those are the ones where I edited a value within the regular editing function, not via the apply to all identical, or when I flagged or start individual rows. Those cannot be exported, but all of the other ones you can select, or you can just deselect all and only select specific ones that you want to keep. And you will then have a JSON representation of that editing step. It notes down the filters as they were applied when this editing was done, what were the parameters of the editing step and everything. And you can copy that or click on export here. And then if you are in a different data set, you can click apply, paste that content here, and do the same steps again. And how to document this? This would be a really good way just to say we have the editing history and we extract all of the steps we did and put this in a file so that people understand what was done. But that, of course, means that they need to have the exact same data set from the beginning with all of the same column headers and the same rows. The other option is just to export it. You can export a data set as an entire project. This will create a zip file that you can load into another version, and you can see all of the editing steps that were done and all of the intermediate versions. So this is like the most complete and secure way to document something. But there are different formats to export the current state. You have to be careful to a certain extent, because if you have filters applied, let's say like this, and you click on export here, you will only export the ones that are currently visible. This is sometimes really useful when you just want to have a subsection, but it can sometimes be confusing when you say, okay, I'm done editing now, I want to export all of the data, and you miss that you actually still have some filters or facets applied, and you don't get an export of the entire data set. There are various different formats here, Excel, other spreadsheets, tab separated values, comma separated values. What's really useful is the custom tabular. So there you can just say, okay, it's a either CSV or a TSV file, a tab separated or comma separated, and you can just select some of the columns that you want to have in there and specify some of the parameters, click download, and it will download the content you selected for subsections of the dataset. And templating. So this is quite useful when exporting to a different format. It already suggests a default JSON expression. You can see the code and you enter something that goes to the beginning of the file, something that goes at the end of the file, something how each row is supposed to be exported, and a separator for the different rows. This means that you can, for instance, put XML in here if you need them in a specific XML format, or SQL imports based on the data set. It's really helpful just to save the values because they don't get saved automatically. That's a bit annoying. In the common transformations, you have the capitalizations option, and there's one option called title case. Basically, every beginning of the word is spelled in a capital letter, and all of the subsequent ones are in lowercase. You can see we now have that name spelled in title case. What is the advantage of cleaning in OpenRefine over cleaning in R? If R works for you, then that's fine. I think in general, OpenRefine is more accessible to people who are not as familiar with the programming compared to similar things in Python. I quite like it because it gives you instant feedback and you can use a combination of automated and manual editing. It automatically saves in the background on your local computer. And if you look at that console window, it will internally occasionally show you after every couple of commands, save project. So you don't need to worry about saving. It's done automatically. However, at the end, when you're done editing, it's important to be sure that the project was saved. Closing the browser window doesn't really have much of an effect on that, but closing this console window means that OpenRefine closes. And I will always recommend to close via pressing the Control and C command here instead of just closing it via X. It's a bit safer. I'm not quite sure how it works right now, but a couple of years ago, it was in the process of writing while I closed it, and it corrupted some of the files. We do have to make a small detour into regular expressions. The regular expression is a really powerful way to match string patterns. It's really common in programming languages, useful tools that help you to create those regular expressions and let you test them. They're on the screen. You have certain patterns, they mean something, and with that you can match multiple strings. For instance, /W is any alphanumeric character, so any letter or number. /D is just a number, a digit. /S is a white space, so a space, tabulator, or line break. And a dot is a placeholder for any character. We have placeholders for the beginning and the end of a string. And if we want to use some of the characters that do have a special meaning within regular expressions, so like a $, we want to match as a $, then we need to escape it using, again, as a slash. And when we put characters in brackets, it means that any of the characters within those brackets can be matched. And then if we put this little tilde before of it, it just negates the expression. And we can also address the spans of characters. So A to Z means any lowercase character here. Or we can work groups with using brackets and the pipe symbol. So that means we either match ABC or DE. And when we combine those, what's called qualifiers, can then say we want to have a certain number of those. So a star is 0 or more repetition of the previous character or group. So when we use brackets, it's called a group, or similar here. The plus means something must occur at least once, but can occur more than that. A question mark, it means 1 or 0. It's optional, but it cannot occur more than once. Curly brackets are special cases for upper and lower bound to the number of repetitions. And when we write something in brackets, we can then address it later on. It's called a back reference. Whatever we matched previously, we can now match again. There are two different ways of expression. Usually a backslash means if you're using it within the regular expression, and the dollar sign means if you're using it in a case of search and replace. For instance, here we can match hello world, whether it's spelled with an A or with an E. Here we have the beginning of a string and the end of the string and the middle point. So we are matching for anything that is just a single character. Here we match either Star Trek, Star Wars, or Stargate. This is an expression for a year ranging from 1970, so we get 19, and then the 70s, 80s, or 90s, and at the end, any of the numbers, or beginning with 2000, and 2000s or 2010s, and then a digit at the end. So anything from 1970 to 1919. And this might look confusing, but if you look at it for a while, you realize that is just an overcomplicated way of writing banana and nothing else. You can search for regular expressions in OpenRefine as well. We have here the check for regular expressions, and most functionalities within OpenRefine support that. If we go back to the collector name, we set all filters, and text filter, use a regular expression, and we say we want the beginning of the string, any character. Let's say we check if we have any names that are 4 characters long. So this is the expression of the point, curly brackets, and 4. That is pretty much the same as typing the dot 4 times. So if I open the curly brackets, then it's an invalid regular expression. It will throw an error here. I need to finish what I was writing before it works again. If you're working with a lot of data, 100,000 rows and more, it's sometimes better just to write out the regular expression beforehand on external tool and then pasting it in here, because for every typing it will try to rematch and it just takes a long time. In OpenRefine, we also have edit cells transform, and this is where we get complex transformations. It's a language called GREL, General Refine Expression Language, formerly Google Refine Expression Language, that has a lot of functions. Like you can use the replace, that's similar to the one that we had the interface before. It can also work with regular expressions. We can split a string and only address some parts of it. You need to look up the functions and the syntax. It's possible to address other columns in here and compare it with another column and do some calculations there. We can add new columns. We go for the editing and edit columns and add column based on this column. For instance, we now have here the full scientific name, and I can say split based on a space. And now we result as an array, multiple parts, depending on how many. And of that array, we want to have the first part, and that will give us the genus. In here, we would take the collection date and match for any 4-digit number, extract that and create a new column based on that and convert it into a date format. We have worked with strings so far, but there are also numbers or dates, and then we can have a facet, a numeric facet here. If we convert it to a number, the year, and we can use a slider to narrow down that number. If you have a really huge data set, it will use the stars and flags. So you create facets by stars and flags, and you narrow down like a subsection of the problem, deal with that problem via search and replace. And once it is done, you can flag the rows that are issues, or you can star the rows that have been cleared out. And you do this over and over. And by hiding the ones that are flagged or starred, you will then only keep the ones that have not been processed in your active view. That one is a regular expression that validates all of the dates in the ISO format, starting from the beginning of the Gregorian calendar until the end of 2019. And it has all of the rules for leap years encoded. That's a way to check if date transformations have worked properly. Once you're done with OpenRefine, just press Ctrl Z or Y. That's just a way to make sure that the project is saved properly before closing. There is a lot more, but this should cover 95% of all your potential users. In here, it's quite clear that we have one of those bracket groups, so it's an A or an E, so either way how you spell hello. What is a bit easier to miss is the question mark at the end, because here we have an exclamation mark. Exclamation mark is just a regular exclamation mark. There's no special functionality. The question mark makes this optional, saying either it's there or not. So you match hello world with an exclamation mark or without it. And so in OpenRefine, matching means it's when you filter for a regular expression, it gets the entire row, even if there's more content than what you wanted. This example, for instance, in OpenRefine wouldn't really be useful just to have this optional character at the end. It will match either way. But if you want to specifically limit your expression to the entire content of the cell, this is where you use this little roof-shaped character to say this is the beginning of the string and the $ is the end of the string. So those are not matched. That just means these are the borders of the content of the cell. Just putting in a single dot into a search, for instance, would mean it would match any cell that has any content. Empty cells will not get matched, but any cell that has any content will get matched if you use a single dot. But if you use it in that combination, then it means it will only match the ones that have just a single character. We see the parentheses and the vertical bars, and that gives us the 3 different groups. Down here, the date, we again have the bigger group, so the parentheses on the outside that are separated by this vertical bar. And then to the left, the first 2 characters are just 1 and 9 as characters. And we have the group here from 7 till 9. So the 8 is part of this one as well. We could have just replaced the dash with an 8, would mean the exact same thing. And at the end, a \d digit. And the second part is structured quite similarly. In here, we could just remove this dash entirely, would mean the same thing, and then another digit at the end. So and here, it's just a complicated way of spelling banana. So let's look at it. We have a B in the beginning, opening brackets. And then we have squared brackets with just an A. That means like any character within those brackets, it is just an A, so there's no alternative. We have the curly brackets 1 and 1. That means it occurs at least 1 and maximum 1. All of this could have just been a single A, but there are multiple ways of writing things, and sometimes those features are useful. And then we close the parentheses, so that is just an A. And then we open up a second group of parentheses with an N, that's just a regular N. And then we have the \1. So this refers to the first capture group, so the first set of round parentheses. This is the same as in here, that's also just an A. And then we have the second back reference. This one refers to the second group. And the second group is again this N and then the A. So this comes down to banana. So where to type these things in OpenRefine? If you're on that interface, if you have a search field, you can check this regular expression and it will then accept regular expressions and it will evaluate them as such. The same goes for, let's say we go here in the menu and say, click on replace, the one I showed you before. In here, you also have the option of regular expressions. This interface is the same as if I were to use the transformation, saying value.replace. And let's say we start with a regular string replacement. Let's just say we turn J1 Müller to Born Meyer. So we replace the name here. And with that view, it's really useful because you can see what will be done. And if you want to use regular expressions in here, instead of using the quotation marks, you use slash here and another one here. And now everything in here is a regular expression. So we can say use the plus for an L that appears multiple times. It will still get matched, but this would now also match triple L. And here we see, for instance, the same name, but with the middle initials as well. That also gets replaced. Let's just do this. These regular expressions would be in Java language. Regular expressions is just a general way that's supported by many programming languages, but there are what are called flavors of regular expressions. Some of the more complicated things are slightly different in different programming languages. Since the backend of OpenRefine is written in Java, it uses the Java flavor of regular expressions. But all of the ones I showed you before, they are pretty much the same, except maybe the back reference. So if we want to use with a replace and we want to reference the capture groups in the replace function, then we need the $sign. And this one is a bit more complicated, but here, this one is a regular expression that takes date formats, and it takes the European style of writing of day.month.year and turns it into year-month-day. So this part is for all of the days, and it either accepts a dot or a comma or a space as a separator or any combination of those. Then we have another group for the month. The leading zeros is optional. That is what the question mark is. And at the end, we have the years. So that's the end of the string. And then we have the replace part. And then we turn the order around. We do a third one, so the year first. Then you have a 0 and the month. And then we have a 0 and the day. Because some of those could have leading zeros, but some don't. For instance, for the day, the 5th of May, we don't have a leading 0. And to handle all of those cases, we just put an additional 0. And sometimes this means that there's a 0 too many, but that doesn't matter because in the next step, we just take the same pattern and correct for those optional leading zeros and print it out as the output date here. And you can see the preview for the columns. Sometimes when there's no value, it will just show an error, but that doesn't matter. We can safely ignore that. We can now try to use this regular expression here. Let's look at what it does. This is the content of the cell. Match means it applies a regular expression and it returns the different results. Unlike in the filter function in here, it only returns the part that actually gets matched. We have a group of a \d that appears 4 times. It would be the same as writing \d, \d, \d. We close the group and we have, again, any content we like, as often as we like. That means it will match the entire string, but only take the first 4-digit number. If we have multiple 4-digit numbers, it will select the last one with that expression. Because by default, each part of the statement tries to get as much content as possible. And only when it's not possible that gets any more, it will then give the part to the next expression. So go into OpenRefine again and say we have the collection date and we go on add column based on this column, value dot match. We have the regular expression of dot star, opening the group, \d 4 times, closing the group, dot closing the regular expression, closing the function, and we now see a preview of the matches. This is always just one because we only have one capture group in here, multiple results here, and since this is an array, we want to use the first element so we get the number. Yes, I now have written this one. I can paste it, give it a new column name here, and create the column. And then I'll quickly do the 2 steps that I glossed over previously. We go to edit cells, common transformation, and say we want to turn this into a number. You could also use it as a date, but numbers for now are simpler, since all of the ones that are in here are 4-digit numbers. The numbers are now aligned to the right and appear in green. And we can now make a numeric facet that shows us the distribution over the years. And here we can say we want to only limit it to results from 1840 till 1900. So that was the content I had on regular expressions, except some of the later examples for you to do this for yourself. The pre-made ones for the 4-digit years, for the month with optional leading zeros, and the days with optional leading zeros. And then, of course, the monster at the end.